Okay, this is another tutorial. It's an example of stoichiometry where we're calculating the grams of a product if we're given the grams of one of the reactants. This is an example from the page 2 of your Unit 9 homework packet. You may have copied this down already in class, but this way you get to see me go through it one more time so that you'll be able to do the other examples on this page in the homework packet. It says the reaction of carbon monoxide and iron 3 oxide produces pure iron and carbon monoxide as the only products. What mass in grams of carbon monoxide has been used with excess iron 3 oxide if 80.4 grams of pure iron could potentially be produced? So I've already written out the equation here, and we want to balance it, of course. And we're given the information that we have 80.4 grams of pure iron that could be produced. And the question is asking me what mass in grams of carbon monoxide has been used with excess iron 3 oxide. So we're producing this much solid iron, pure iron, and we're starting with excess iron oxide, but we want to know how many grams of carbon monoxide were necessary to produce this. So again, when we have something in excess, it means there's plenty of it. It's not limiting how much product we are making. We're going to start with the number that we're given, 80.4 grams of iron. And the first thing we'll do is do our calculation to go from grams to moles. This is the molar mass of iron from the periodic table. And then the next step is the mole ratio that we've been learning. And whatever substance is here is what goes in the denominator here. So iron is going to go down here. And what I'm interested in finding out about is carbon monoxide. So that goes up here. And then we're going to put in the coefficients that are in front of both of those two substances in our equation. There's a 2 in front of iron and a 3 in front of carbon monoxide. So this is the mole ratio in this equation of those substances. There's a 3 to 1 to 2 to 3 ratio in terms of moles in this equation. And then our next step is where we're converting back to grams then, but we'll be using the molar mass of carbon monoxide to calculate grams of carbon monoxide. So this is the molar mass of carbon monoxide. If we were to calculate that from the mass of oxygen and carbon from the periodic table, and then by multiplying what's on the top and dividing by what's on the bottom, your answer should be 60.5 grams of carbon monoxide. This has been another example calculation of how to calculate the grams of one of the reactants necessary to produce a specific amount of product.